Today we are going to look at, still on storage classes, but today we are going to look at the third part, which is what? The register storage class. So we're going to look at register storage class, right? I told you these are like the thinkers and the executors in the society. We are classifying the CEOs of the company, the government, right, of a country or the society inside into this class. So these guys, their chamber, right, are connected to the heart of the community. So they actually convert thought into actions. So this register storage class will tell the compiler to save a variable into the register of the CPU. So you cannot use address of for it because it doesn't have address. But the compiler can decide to ignore it depending on the optimization. Meaning, if there is no space in the CPU register, it can store the variable in the stack. So let's write a program to demonstrate this guy. So following the same pattern, so I'll say include stdio.h, my preprocessor directive. Then I'll say void register example. So I'm creating a function, register example. So I'm creating a function. The function is not going to return anything. That's why I say void. And then it's not accepting any parameter. So inside it, I will say register int counter. Now I'm not going to initialize it. So I'm creating a variable counter and the integer rem, meaning this is how I'm going to interpret the binary 0 and 1. But this register keyword here is telling the compiler where to save this variable counter. Now I'm going to use a for loop to access the variable, right? So I'm just going to say for. Inside it now, I'm going to initialize counter assign 1, right? Then I will bring out my condition. Counter less than or equals to 5. Then counter plus plus. Okay, so that is my function. Inside this my function now, I am going to say print f counter equals %d/n, then counter, right? Okay, so I'm going to close my for loop here. Then I will close this one. So this is for this, and then this is for my for loop. Then my main function, I will say int main function. Inside my main function, I'm going to call my register example. So I will say register example. Then I will say return 0. Then I will close this. All right, so this is my program. So I've created a function here, and I'm calling the function inside my main. So what happens is, the moment the compiler encounters this register, which is the storage class, So same thing, we are going to do memory location. So location, scope, lifetime, and then default value. Default value. So the moment the compiler encounters this register, the register is a keyword that is telling the compiler to load this memory variable in the register of the CPU, right, for fast access. Then I'm going to use my for loop. So I will initialize that register to what? 1. And then I will use my condition to check. If counter is less than or equals to 5, go in and print out counter. Then increment counter to the next value. So what it will do is to create a memory. So this is inside the register of the CPU. So it will initialize it to what? 1. So this variable, the location is in what? Is in the register. That is CPU register. The scope is within this function, meaning when you exit this function, it ceases to exist. So the scope is just within the function. Then the lifetime is also within this function. And then the default value of register is also what? Garbage value. Garbage value. So that is the default value. So it will initialize it to 1. Then it will check counter is less than 5. That is true. It will come in and it will print out counter. It will print out counter equals to what? 1. Then it will increment counter to 2. Then to check the condition, counter is less than or equals to 5. That is true. It will come in and it will print out counter equals to 2. Then it will increment counter to 3. Then it will check counter is less than or equals to 5. That is true. It will come in and it will print out counter equals to what? 3. Then it will increment counter to 4. Then it will check the condition, counter is less than or equals to 5. That is true. It will come in and it will print out counter equals to 4. Then it will increment counter to 5. Then it will check counter is less than or equals to 5. That is true. It will come in and it will print out counter equals to 5. Then it will increment counter to 6. Then it will check counter is less than or equals to 5. That is not true. It will come out of this loop and it will return back to what? To the calling function. But then it has printed this out on the screen. So this is the part that is connected to what? To the CPU for easy access. But if the compiler checks and there is no space in that CPU register, right, it's going to load this into what? Into the stack. That is what you have to understand. So that is the purpose of what? This register storage class. The location is what? CPU register. And the scope is within the function. The lifetime is also within this function. So once you encounter this one and you exit, everything will be gone. If you call it again, the process will start afresh and it will start counting from 1 to 5 again. So meaning if I call this register example again, it will repeat the same step. So let's go to code blocks and let me demonstrate this for you to see. I'm just going to demonstrate the register example that I did on the board. So this is the script. I created a function again. The function is not returning anything. That is why it is void. And it's not accepting any parameter. So it's just going to print out whatever it is in this variable. So register int counter. So register is telling the compiler to create this counter, store it in the what? In the register of the CPU. So I initialize the counter to 1 and then use this condition to check and then print out the value on the screen. So I'm calling the counter here and then I will see the output. So it's going to print out counter equals to 1 to 5. Then let's run it and see. So you can see printed out counter equals to 1, counter equals to 2, counter equals to 3, counter equals to 4, and counter equals to 5, and then it will exit. So if I call it again, it's going to execute everything all over again. So let's run this script to see. So you see, it printed out counter equals to 1 to 5. And then when I call it the second time, it also did the same thing. Counter equals to 1, 2, 3, 4, 5. Because when it exited the first time, everything is gone. And then when you call it again, it's starting all over. So that's what I want to show you in this register example. So you will see in the next class. Don't forget to give me a thumbs up. Bye-bye.